22HND, which is the router we're going to be configuring today. So I'll click on the MAC address, which will load that into the Connect to line, and I'll click Connect. And now we should see Winbox on our screen with giving us the capability of configuring this router. The first thing that I want to do is to set the router back to the factory defaults, because in our case we have a configuration on the router which we prepared with QuickSet, but we want to remove that configuration and basically start with a blank slate. So to do that, we're going to click the System button and go down to the Reset Configuration. Now here we have the option of checking No Default Configuration, and we're going to do that so that the device will not load the RouterOS default configuration and then just make us have to remove that a second time. So we'll do this now. We'll click Reset Configuration, and then of course a reboot is required. So for purposes of our demonstration today, what I've done is taken the same router that I just reset the configuration on, and I've downgraded it to version 4.17 of RouterOS, because previously we were running the latest version, which at the time of this video recording was version 5.24. So I've downgraded this router to 4.17 so I can demonstrate for you the upgrade process. Now, upgrading a router is something that you typically want to do when you first receive the router, because many times there are bug fixes that have been applied to the operating system, and we want to have the latest, greatest version of the software when we set this router up for the first time. Now, in order to get the latest version of RouterOS, we can do that from Microtik's website. And if you've not been to their website before, the address is www.microtik.com. Once we get there, there's a download tab. We can click the download tab and then find the architecture of the device that we're trying to do the upgrade on. In this case, it's the RouterBoard 751, which is the MIPS BE architecture. And there's a number of different versions that are available, 4.17, 5.24, and the release candidate for version 6. We're looking for the most stable version possible, so that's going to be the latest version that is not a release candidate. In this case, it's version 5.24. There's a number of packages here, but the one that we actually want is called the upgrade package. This puts all of the most common features in one file. Also available is an all packages zip file, which contains features that we probably don't even want to use at this point in time. And it is really just for advanced configuration. So let's grab the upgrade package, and so we'll do that by saving the file. Now, during the break while ago, while we were waiting for the reboot, I switched over to my Windows operating system, which I have running in parallels on my Mac. The reason I switched to Windows is that the Winbox utility running in Windows gives us the ability to do drag and drop, which we can't do when we're emulating Windows under Wine with Mac OS. So now we're running a Windows version of Winbox, and I have the file that we've downloaded here, which is the RouterOS MIPS-BE-5.24.mpk file. So in order to do the upgrade, I'm going to click the Files button, and I simply drag this file into the Files window and drop it there. You have to make sure that you drop the file in the root of the file folder. Sometimes if we have installed some optional packages or enabled some things like Hotspot, there may be multiple files in this file window, and dropping the file in the correct place to get it into the root of the file system may be a bit difficult with this drag and drop. So one little trick that I like to use is to click the backup button within the Files window. When you click the backup button, it creates a backup image of the router with all the configurations stored. And by doing that, we add a little space at the top of the window. So you can imagine if there were a lot of file folders within this window, it might be difficult to get our file where it needs to go. So by clicking the backup button, we add a file at the top of the list, giving us a little space where we can drop our file into the top of the list. Now, in order to upgrade this router to the 5.24 code, all we have to do at this point is to issue a reboot command. And it's important to note that simply unplugging the power from the router is not sufficient to cause it to upgrade. We have to actually issue the reboot command. And we do that by clicking System and Reboot and accepting the answer of yes. Once the router reboots, we should have version 5.24 installed and running. Alright, so we're logged back into the router now, and it's running version 5.24, and we're ready to set up the basic configuration for our routerboard 751U-2HND. The first thing we need to do is to label our interfaces so that we can keep track of what's going on here. Now, I'm not a big advocate of actually changing the interface name, which is certainly possible, and some people do recommend doing that, but I would rather use comments because it keeps things more standard and it's easier for me to go back later and to work through the configuration. So the first thing I will do is click the Interfaces button and go through and label each of my interfaces. In this case, I'm going to make Ethernet 1 my WAN interface. And so I simply click this yellow square that looks a bit like a post-it note, and here I can put a label for the interface, and I'm going to call that WAN, or Wide Area Network. So that will be our configuration for our WAN interface, and the one that will connect to our service provider. In this case, this router has 5 other Ethernet ports, and as you can see, Ethernet 5 is in the running state, meaning that this is the one that I am connected to with my Ethernet cable. This device also has an onboard switch chip, which means that I can switch each of these interfaces together and slave them off of another interface. So in this case, I'm going to pick Ethernet 2 as my master interface, and in the comments I'm going to put LAN for Local Area Network, and I'll also add a note here that all ports are switched off either 2. And this will remind me that all of my ports are appearing together in a switch group. Then I'll double click on Ethernet 3 and set its master port to Ethernet 2. And then I just continue doing the same thing for Ethernet 4 as well as Ethernet 5. Now, you may notice that there was a brief break in the video. That's because when you add a port to the switch group, you will lose connectivity to the router when that port is finally added, and since we're accessing the router through Ethernet 5, it did kick us out of Winbox, which is a normal behavior. We simply logged back in and finished. So now you can see all of the ports have an S next to them that are in the switch group. This means that all traffic that appears on Ethernet 2 will also be available on ports 3, 4, and 5. So we've basically just created a small 4-port switch. The next thing we need to do is to add an IP address to our WAN interface. Now this can be done statically if our provider has assigned a static address to us, but it can also be done using DHCP. And so I'll show you both methods at this time. To add an address via DHCP, it's done by clicking the IP button and the DHCP client, clicking the plus sign, and then selecting the interface on which you want to add the DHCP client. In this case, I'll add it to Ethernet 1, and it's going to say searching right now because there is no DHCP server on our network. If there were, it would acquire an IP address, add it to the Ethernet 1 interface, and it would also add a default route. So in our scenario, we're going to go ahead and delete this DHCP client, and we're going to add our address manually. To add an IP address manually, we click the IP button, then the addresses button, and click the plus sign. Now, RouterOS uses slash notation or CIDR notation. So you're going to need to know the size of the subnet that your provider has assigned to you. In this case, we're going to use the IP address they've assigned us, which is 216.81.35.2/24, because our address is on a Class C subnet. Under Interfaces, we're going to select Ethernet 1, which is the default, and at this point it is not necessary to fill in the network, and in fact I recommend that you don't fill in the network statement because you may make a mistake. The router knows how to do the math, and it's able to fill in the network statement for you. At this point we can either hit apply so we can see the result of our changes, or we could simply hit OK. And now we have an IP address that is bound to our Ethernet 1 interface. The second thing we're going to need to do to get this router working is to add a default route. So in this case I will once again click the IP button, but I'll go down to routes. You'll see there's already a route there, which is the connected route that is added by the router itself when we added that IP address. In this case I'll click the plus sign and I'll put in my default route. All zeros /0 designates the default route destination, so all we need to do is click on the gateway blank and put in the address of our gateway, which is 216.81.35.1. Again, this is assigned to us by our provider, and we do not want to fill in any other information for the default route. At this point I click OK, and it says unreachable because at this point in time I don't have anything plugged into my Ethernet 1 interface. So our next step is to set up our DNS server so that not only can our router resolve DNS, but it can also provide DNS resolution for hosts that are on our network using this router by using caching DNS. And caching DNS can speed up the network because it reduces the number of times the router has to go to our authoritative DNS server and do resolution by caching the DNS locally. So to do that, we're going to click IP DNS, and we're going to put in a DNS server. In this case we'll just use a public DNS server because that's the easiest thing for this demonstration. We're also going to click this check mark to allow remote request, and that's what actually puts into place the caching DNS server and allows our router to resolve DNS. If we want to check to make sure that things are working correctly so far, we can do that from a terminal where we can type ping 8.8.8.8, which is our DNS server, and we're getting a reply from it, so we know we have connectivity. But secondly, we'll try pinging something like Google, and we instantly get a response from Google, which means that DNS resolution is working correctly on the router. The next step is to set up NTP, or the Network Time Protocol. Now, as you may be able to guess, these small low-cost routers do not have any type of onboard power or battery to keep the clock running when the router is disconnected from power. So because of that, we'll use an NTP server to get the correct time, and we'll set the clock appropriately. To do that, we simply click System and SNTP Client, click Enabled, set the mode to unicast, and put in a DNS resolvable name for a public NTP server. In this case, I'm going to use us.pool.ntp.org, and then I'll drop the US and just simply put pool.ntp.org for my secondary NTP server. And this will help ensure that we get two different NTP servers. Now we can hit apply, and those addresses should resolve differently, and click OK. The next step is to set the system clock, and we do this under System and Clock and selecting our local time zone. In my case, it's going to be America and Chicago, and I'll hit apply, and now my router has the correct time and the correct date. Now, using SNTP is a pretty simple step. It's not resource intensive, and it ensures that values in your log actually make sense to you. So now when we click the log button and we see entries appear in our log, instead of having a January 2nd, 1970 date, they have today's date as well as the time of day that the log entry was made. So for troubleshooting purposes and security, it's just a much better option. Okay, so now we have our IP address set, we have DNS set up. The next thing I like to do is to set up the system identity so that when we use the Winbox utility, we'll be able to see our router on the local area network. When you do a scan with Winbox, router identity is one of the options, and currently ours says Mikrotik, which is the default. So I'll click System, Identity, and I'll set the identity of the router to Mikrotik, Home Router. and that can be anything that you want it to be. And that name now appears in the title bar at the top of the Winbox window. It also appears on a command prompt when you open the command window in the router. And then finally, more importantly for what we're doing here, it shows up when we click the scan button as Mikrotik Home Router. Alright, we have all of the basics in place for the router to have connectivity to the internet. So now we want to set up connectivity for our local area network. We have a wireless device installed in this router from the factory. So this enables us to not only create wireless connectivity but also wired Ethernet connectivity. So to do that, we want to join both of those interfaces together into a logical interface and then do all of our configuration on that logical interface. The logical interface I'm speaking of is called a bridge interface, and bridges are created from the bridge button. The purpose of a bridge is to join together two physical interfaces, or more physical interfaces if you want, into a single logical interface. So to do that, I'll create a bridge by clicking the plus sign and simply accepting the faults and clicking OK. Then on the Ports tab, I'll click the plus sign again. I'll add Ethernet 2 onto my bridge by clicking OK, and I'll add my wireless card, which is WLAN 1, onto my bridge interface. Now since Ethernet 2 through 5 are already switched together in a switch group, I've effectively added all of the ports to this bridge. With the bridge configured, my next step is to create my connectivity for the local area network. This is done by clicking the IP button and going to addresses and creating a new IP address. This IP address we're going to put onto the bridge interface, and that will allow us to address the network on the LAN side from both wireless as well as the wired Ethernet interfaces. In this case, I'm going to go with something conventional like 192.168.1.1/24, which is a Class C network using RFC 1918 addressing. Now, in simple terms, RFC 1918 simply defines the private address space that we can use on our local area networks. This address space is never routed through the internet, and this is the correct way to set up our router. Now, which subnet you choose is entirely up to you, but this is the one I've chosen for this demonstration. On the interface, I'll select Bridge 1, click Apply, and I'll go ahead and put a comment in here that this is the LAN IP subnet. I'll hit OK, and it appears there. Alright, so we've got an IP address on our bridge interface. The next step is to create a DHCP server, which is really simple in RouterOS. To do that, I'll click the IP button and DHCP server, and on the DHCP tab you'll notice there's a DHCP setup button. Click the button, we select the interface on which we want to run DHCP server. In this case, we'll put it on the bridge interface. We click Next, and we can accept the defaults from here forward. Now, your DNS server does need to be a real DNS server. In this case, we're going to make a little change here, and we're going to put in our IP address of our router itself on the local area network. The reason is this is the DNS server that will be given to computers that are connected to this router. And since we have caching DNS turned on, we're actually going to tell our host on the network that our router is their DNS server, and that will make the caching DNS work properly for us. We hit Next and just accept the defaults, and DHCP setup has completed successfully. So with DHCP set up, as well as our WAN connectivity, the last step is to set up the wireless interface itself. The wireless features in RouterOS are really powerful, and because of that it can be a bit overwhelming sometimes. So I'm going to show you the things that you need to set up, and we won't go into all of the advanced options that probably aren't necessary for your setup. So to get to the wireless interface, you may have noticed I click the wireless button, and there we see the wireless interface, and I'm going to click the check mark which will enable that interface. Next, I'll double click the interface itself to bring up its properties, and I'll go to the wireless tab. And one thing you may notice here is this advanced mode button, which is a toggle button. If we click advanced mode, we get a lot more features, many of which we may not even need. But since this is a more advanced video, we'll go ahead and work in advanced mode. The first step is to set the router to AP bridge mode. This is the access point mode that will allow it to support multiple stations. Next, we're going to set the band on 2 GHz B, G, or N so we can support the widest range of our users. Channel width we'll leave at 20 because we're supporting laptops, and 20 MHz is the standard channel width. Now for the frequency, we have a little bit of flexibility here. What I'm going to recommend is that you use something called dynamic frequency selection, or DFS mode. And we're going to set DFS mode to no radar detect. What this will do is, once this interface is enabled or the router boots up, it will scan for frequencies looking for one that has the least amount of interference and traffic on it. Once it finds that frequency, it'll lock in and work like an auto channel mode. The next thing we'll set is our SSID, which is what we're broadcasting wirelessly for clients to associate with. In this case, I'll just set it to my home router. Next is the wireless protocol. We need to set that to 802.11 to support our laptops. And that's all we're going to change at this point because we need security, but that's actually created in another place. The next thing we'll do is click on the HT tab and make sure all 4 chains are selected. This will allow us to run in MIMO mode when we're doing 802.11n. And we'll click OK. Then we'll jump over to the Security Profile tab, click the plus sign, and create a new security profile. We need to give the profile a name, and in this case I'll call it WPA2. On the authentication types, we'll leave the default of WPA PSK and WPA2 PSK, and make sure that we only select the AES, unicast, and group ciphers. I do not recommend using TKIP. TKIP requires more router CPU to operate and also creates a lot of compatibility problems with many of the products that are out there nowadays. The pre-shared key is where we're going to put in the passphrase that we're going to use for our clients. In this case, we want to make it fairly complicated, so it's not really easy to guess, but for purposes of our demonstration, I'll call it Mikrotik Training Video. And sometimes it may be a bit difficult to see what we've actually typed in if we make a mistake. So there's a feature up at the top of Winbox called Hide Passwords. And if we uncheck that, we can actually see what we typed in. And I'll copy that and paste it into the WPA2 pre-shared key and click OK. So here's our security profile. The last thing we need to do is to apply that profile to our interface. So back to the Wireless Tables Interfaces tab, double click WLAN 1, skip over to the Wireless tab, and go down to the Security Profile, and we will set it to WPA2, and hit Apply, and OK. The last thing that we need to accomplish is to create a masquerading rule for our router. And the purpose of this masquerading rule is to hide our private IP address behind our public address. So I'm going to reattach to my router, and I'm going to click the IP button and the firewall button. Next, I go over to the NAT tab, and I'll click the plus sign and create a new NAT rule. This rule, we're going to select the source NAT chain, and we're going to match any traffic that's going out our interface Ethernet 1. And this is traffic that's going typically to the internet. On the Action tab, we'll click Masquerade, and we'll hit OK. So now the last piece of our configuration will be to install a firewall to protect our router and to protect the clients that are behind our firewall router. So to do that, we're going to click the IP firewall button and create some filter rules. Now these filter rules will be put in two different places. One is on the input chain, and that will protect the router itself. But secondly, on the forward chain to protect the laptops and the other computers that are behind our firewall. We're going to use two different basic types of rules. The first will be a straight filter rule that will filter traffic based upon IP address, and the second type of rule will be a stateful rules, or a set of stateful rules that will allow us to filter based upon connection states. And that's really one of the very powerful features of RouterOS, is this ability to filter based upon connection state. So I'm going to use a feature called address list, and this allows us to create just a handful of rules and then have those rules applied to many different IP addresses based upon entries in our address list. So to start out, under IP firewall, I'm going to click the address list tab and create some new address list entries. The first entry, I'm going to name it our local LAN, or local area network. And here I'm going to put the subnet that we created, 192.168/. Here I'm going to put the subnet that we created, our local area network, 192.168.1.0/24. I'll click OK. I also may want to allow access from some other subnet. In this case, I'll pick 10.0.25.0/24, which is our network here in the office that I'm using to configure this device. And once again, I'll click OK. Now, both of these address list entries can be added to a single firewall rule and allow access to this router now. Back to the filter rule tab, I'll click the plus sign, and we're going to create these rules on the input chain. On the advanced tab, I'll select the source address list as our local LAN, which is the address list we just created, with an action of accept. I'll hit apply, and I'll put in a comment that says allow access to the router from the LAN. Now, I like to add some additional information here as well, like allow access to the router from the LAN using an address list. And this helps remind me later that if I want to allow other addresses, I'll just simply look for the address list that is referenced in this rule. And I'll hit OK. So this rule is going to protect the router, but only if we add a second rule. And that second rule is what we call the drop rule. And that rule starts out and it says, on the input chain, with an action of drop. Now what this does is drop all traffic that has not been previously allowed. And once again in the comment, I'll put drop all other traffic to the router. So now a quick review of what these two rules are accomplishing for us. And remember that the firewall rules are processed in order within the chain. So the first rule that matches is the one that will actually process the packet that's entering the firewall. The first one says on the input chain, that is traffic going to the router itself, if the source IP address appears on a list called our local LAN, we will accept that traffic. And remember, our address list contains the IP addresses for our local area network, plus any other addresses that we feel like are safe IP addresses. The second rule in the chain says everything else coming into the router itself, drop that traffic. Now we can see that the first rule is accepting most of our traffic because the packet counters are incrementing rather substantially as we're just simply configuring the router. And if we reset all of the packet counters by clicking the Reset All Counters button, we see that most of the traffic is hitting our first rule. In fact, we aren't dropping any traffic right now at all. So the first two rules, again, are on the input chain, and they are simply to protect the router itself. Now we're going to create rules that will protect the clients that are behind our firewall. All of these rules are going to be done in the forward chain. That's where packets will flow that are going to our local area network through the router. Secondly, we're going to use rules with connection states. And connection states are one of the things that makes RouterOS's firewall facility so powerful. States allow you to look at the state of packets and connections that are flowing through the router and make decisions based upon those states. And it is, again, a very powerful way to create a stateful firewall. So the first rule we're going to create is going to be on the forward chain. And we're going to say that if a connection is a new connection, and if it comes in our local area network interface, which is our bridge interface, we're going to accept those connections. And again, we'll add a comment. And in this rule I said allow connections from the LAN. And you notice that I've changed the selector to the input chain while we were looking at the input chain rules. If I select all, I'll see all rules in the firewall. And if I move this to forward, I'll only see rules that are in the forward chain, which is what we're working with now. So our first rule says allow in the forward chain connections that are coming in the bridge interface with a state of new. The next type of connection that we need to allow is a connection state of established. And once again, we'll add a comment. The next type of connection state that we want to allow is related. This will allow protocols like FTP to work properly. Okay, and then once again we need a drop rule because we've already defined the types of connections that we believe are acceptable, and we'll add a drop rule at the end here to drop all other connection states. And that is our very basic firewall. Now we have to do just a little bit of fine tuning to make this work in all possible scenarios. And there's one more connection state that we can look for that will help secure our router as well. So we'll create one more rule. Again, this will be on the forward chain, and we'll be looking for a connection state of invalid. Now, if you're not familiar with invalid connection packets, these are packets that aren't SYN packets, so technically they're not able to create a new connection. But they're also packets that are not part of an existing source and destination address or port combination that we currently have in our connection tracking table. So they're kind of oddball packets, if you will. And there's really no reason to allow invalid packets, so we're going to go ahead and just drop those. And once again, we'll comment that as well. And because they offer no benefit to us, we'll just drag that rule to the top of the list so that we drop invalid connections before they're processed by any other part of the firewall. So I'll go back to my selector for all rules, and what we should see is all the rules we've created in both the chains of the router. The last rule we're going to add is going to be on the input chain. And once again, we're going to use a connection state matcher here. The purpose of this rule is to allow us to do things from the router itself, like ping hosts on the internet, or to download some files using the built-in fetch utility in RouterOS. So currently we're allowing connections that are coming from our local area network, but we're dropping all other traffic. Now, one other thing this will break is our DNS resolution, because we're going to have to open a connection from our router to a public DNS server and get our DNS resolution so we can cache it locally. And with these two rules, we can't even allow that inbound traffic for DNS resolution. So to do that, once again, we're going to use connection states. So I'll create a new firewall rule on the input chain, and we'll look for connection state of established. And the action once again will be accept, and our comment will say allow established connections to the router. And I'll hit apply. There's one other trick that I'll show you here, and that is the ability to copy rules. So I'll just copy this rule, which copies the comments and all, and the connection state I'll change to related. This will allow an FTP client, if we had one on the router, to work properly as well. The last thing we'll want to do is to change the comment on our rule that we copied, and I'll just simply change that to related. Hit OK, and then finally to move our drop rule all the way down to the bottom of the list. So, quick review of our rules. First, the input chain rules. The first one says allow on the input chain a source address of our local LAN with an action of accept. The second rule says on the input chain, if the connection state is established, we will accept that. The next rule says if the connection state is related, we'll accept that. And the last rule in the input chain says all other traffic, drop it. And then quick review of our forward rules. The first one says drop on the forward chain a connection state of invalid. Allow connections in a state of new if they come from our bridge interface, which is our local area network interface. Allow established connections on the forward chain. Allow related connections on the forward chain. And then finally, drop all other connections on the forward chain. And that's it. You have a very functional firewall with only 9 different rules, and we're protecting both the router itself as well as our clients behind the router. Now, one other note that I'll make for you, and that is that when you're adding these drop rules, you may actually lose connectivity to the router if you've written the rule incorrectly. So one way to protect yourself is to use something called safe mode, which is this button here at the top of Winbox. So when you click safe mode, any changes that you make to the router will be lost if you crash out of the router or you disconnect from it. So add all of your rules in safe mode. Once all the drop rules are in place, simply launch a new terminal. Make sure you still have connectivity to the router. If you do, uncheck safe mode and all your settings will be saved. So that's it. That's all you need to do to set up a RouterOS device with both wireless and wired connections, to put into place a masquerade rule, and to create a very functional, stateful firewall. So I appreciate you joining us today. Hopefully you learned something about RouterOS, and I would encourage you to check out our YouTube channel